Okay, so first of all, I want to discuss real briefly here remind ourselves what an inverse function is, okay, and then talk about, how we get an inverse function, and then also what functions actually have inverse functions, okay. One thing I will emphasize to you is make sure that you learn your terminology, okay. On the test you guys took on Tuesday, from what I graded so far, some people were a little shaky on the terminology, things like coterminal angles, reference angles, and those sorts of things. Also, get used to working in both radians and degrees. Okay, some of you are trying to convert everything over to degrees because you're comfortable with that. Okay, if you're given a problem in radians, stick with radians. At least give your final answer in radians. Okay, but let's address the questions here. What does an inverse function do? Eddie?
Oh, I was scratching my eye.
Well, do you know?
Go ahead. What was the question again?
What does an inverse function do?
Inverse of a function.
It inverses a function? Okay. What do you mean by that? Can someone help?
Oh, maybe y equation put into another equation to find s equal x.
Okay. You're putting one function into another function or equation into another equation and it gets you to x.
Yeah.
Okay. Rachel?
It flips the x and the y values.
Okay. When you're trying to find an inverse function, you would switch the x and y values. Like here, if we were finding the inverse of sine, we would make it x. We would make it x equals sine of y, and then we'd have to solve for y. Okay. Does anyone remember what the inverse function looks like? The what?
It reflects over the x-axis.
I'm sorry.
It reflects over the x-axis. Like when you have the parabola.
Oh no, it doesn't.
Not over the
It
x-axis.
just flips on one of the points, right?
It flips over the line
Okay.
y equals x.
There we go. It is a reflection, but it's a reflection across the line y equals x. Let's say we had the line y equals x here. Okay. If we took anything and reflected it, let's say we had, y equals x squared, like this. Then when you reflect it across the line y equals x, it would look something like this, okay? We were trying to get an inverse function.
So inverse is just reflected across the line y equals x.
Exactly. Now, here's the thing though. Is what I got here an inverse function?
No, well, it's not a function.
It's not a function at all, alright? Because this fails the vertical line test. Okay? Now question, how do I know before I even reflect it that this is going to not have a inverse function?
Because
Caitlin?
if it doesn't pass the horizontal line test.
There we go. We had that horizontal line test. And the term here was 1-to-1. A function had to be 1-to-1. In other words, not only does every x go only to one y value, but every y value is only mapped from one x value. Okay? Here, this fails the horizontal line test, so it does not have an inverse function. Okay? Alright, an inverse function, if this is f of x, and this is, if I have x, and this is f of x, so this is my domain, and this is my range, okay? It takes, f of x takes a value of x and maps it to a certain value here, okay? The inverse function is going to take this value, and if it's 1-to-1, it'll take us right back here. If it's not 1-to-1, when it tries to bring this back, it's going to have like different possibilities of what it could map back to, So it's not an inverse function because there's that uncertainty there. Did I get to the right one? Okay? So an inverse function will only go to one value when I try to map it back. Okay? And we would use the notation f inverse of x. Okay? Does that all make sense so far? Just trying to refresh our memories as to the concept of the inverse. Now, here I have sine in red, cosine in blue, and tangent in green. And the problem is that none of those are one-to-one. Okay? However, we do have an inverse sine function, also known as the arc sine. We have the inverse cosine function, also known as the arc cosine, and we have the inverse tangent function, or the arc tangent. So how could we take something that fails the horizontal line test, like every periodic function will, and get an inverse to it? What could we do here? Restrict the domain, okay? You guys remember that question on the quiz way back when I asked you to find the inverse function and also identify the domain and range. And you guys had a radical function, and on the radical function the range was only x is greater than or equal to 0. But then when you found the inverse, you made it y equals x squared, and a lot of you were saying that its domain would be all real numbers. Okay? But because they were inverses, it had to have the same domain as the original function's range. They switched, and we'll see that again here later. The key was, in order for it to be an inverse function, you had to limit the domain. So what I want to do now is I want to take a look at these one at a time and see how we would limit the domain. And then we're going to see the graph of the inverse functions and look at their domain and range. Okay? All right. So let's start out with sine. Okay? How could we limit the domain of sine so that it will pass the horizontal line test?
Like how you did the inverse function?
Don't worry about the inverse yet. Right now, all I want to do is limit the domain. So it's not going to be all real numbers again, or anymore. I need to limit it so that it will pass the horizontal line test. Miriam?
Maybe like from negative pi over 2 to pi over 2.
Okay. Negative pi over 2 would be right here, right? So if we limited it so it just went from here up to here,
So from a min to a max, or from a max to a min.
okay? Yeah. There's more than one way we could do it, but that actually is the way that we will do this for the inverse sine. Question?
You said an asymptote or no?
It wouldn't be an asymptote. All we're doing is we're just saying instead of making our domain all real numbers, we're going to make our domain go from negative pi over 2 to pi over 2. Okay? Now, as a result, okay, I don't have this part of the graph anymore. I don't have this part of the graph anymore. Okay? We're just looking at that blue portion. So if we were to pass a horizontal line through it, we're only ever going to hit one point. So it passes the horizontal line test. And now if you think about what happened when we reflected across the line y equals x, all the x and y coordinates switch. So instead of the point pi over 2, 1, now I'm going to have the point, 1 pi over 2. 0, 0 will still be 0, 0. But instead of having negative pi over 2, negative 1, I'm going to have negative 1, negative pi over 2. So what does this look like? It looks like this. Okay? Here are those points we just mentioned. 1 pi over 2, negative 1, negative pi over 2, 0, 0. And you can see it's this little part here reflected across the line y equals x. Okay? Now, what is the domain of this arcsine function, which you could also write as inverse sine? What's the domain?
From negative 1 to 1.
Negative 1 to 1. Good. Negative 1 to 1. And what's our range?
From pi over 2 to negative pi over 2.
Exactly. Okay? So, our domain and our range are simply the reverse of what the original sine function was. Okay? Does everyone understand what we've done here?
Yeah.
Does it make sense? Okay. Now, yes,
So you're trying
Cal.
to get it so that it only passes through it one time.
I'm sorry, what?
So you're trying to get the sine graph so that the horizontal line only passes through it one time.
Yes. Because if it only passes through, if a horizontal line test passes through the original function only once, that means any vertical line will pass through the inverse only once. Okay. Now, this is important because you got to understand, as you guys use your calculators to find angles using the inverse sine, your calculator uses this domain and range. In other words, you can't plug into your calculator the inverse sine of a negative 2 because that's outside of our domain for inverse sine. And you know that sine can't be negative 2 anyways, alright? Sine can only go up to 1 and down to negative 1. But also, no matter what you plug in, your answer is always going to be in this range right here. In other words, your calculator is always going to give you an angle that's either in the positive in the first quadrant, or if sine is negative, it's going to give you an angle in the fourth quadrant. Okay? You might say, well, what about angles in the second or third quadrants? That's what we're going to look at in a little bit. Okay? So, there's our inverse sine. Let's think about inverse cosine. Okay? Again, we need to limit our domain. What would I limit my domain to in this case?
0 to pi.
Very good. I'm going to go from 0 to pi. Okay? Now, that's not the only way I could do it, but that's going to be the easiest, and that's what your calculator will do as well. Okay? So, my domain, I'm now limiting to go from 0 to pi. And what does this look like? Again, it'll reflect the coordinates of the points so that instead of 0, 1, I have the point 1, 0. And instead of the point pi negative 1, I have the point negative 1 pi. Okay? And you can see here again, the domain and range have been switched from what I had it for cosine. Alright, so this is arc cosine of x or the inverse cosine of x. Okay? Now, if I were to punch in inverse cosine of something into my calculator, it's always going to give me an answer between what and what? 0 and pi, or 0 and 180. So it's always going to give me an answer that's in the first or second quadrants. Are my answers always going to be in the first and second quadrants? No. So there's going to be something we're going to have to do in order to adapt to that. Okay, depending on the circumstance. All right. Our third one, tangent. Tangent, we didn't spend a ton of time looking at the graph of this earlier, but you've seen this before. You know we have these asymptotes at negative pi over 2, pi over 2, 3 pi over 2, and so on. Okay? But I'm going to limit my domain again. What would I limit my domain to be? Alexi?
Negative pi over 2 to pi over 2.
Very good. Now, what's going to be a little different about this one than the previous two?
It'll go on forever.
Okay, it's going to go on forever because tangent goes up and down forever. But in how I'm writing my interval here, what am I going to use that's different than how I wrote it back here?
The parentheses.
Back here. I'm going to use parentheses, right? Because it can't actually equal negative pi over 2 or pi over 2. So I would use an open interval. All right? So let's look at this. Notice I have vertical asymptotes here. Those are going to become horizontal asymptotes. And notice what I've got. I've got horizontal asymptotes at pi over 2 and negative pi over 2. But it goes forever in both directions. So my domain for the inverse tangent is what? What's the domain? All real numbers. Okay? And my range is?
Pi over 2 to negative pi over 2.
There you go. Okay? Again, we're just switching the domain and range from the original tangent to be the domain and range of our inverse tangent. Okay? Everyone with me so far?
Yep.
All right, now grab your calculators out. We're going to practice using these. Okay, on your calculator, you'll notice above the sign button, it doesn't have to be even a graphing calculator. Just you get the one that you're going to be using most. Okay? Make sure your calculator is in degrees, please. And you'll see the little sign -1 above the sign button. Okay? You need to hit that second sign. All right, I need to reopen this because it's. You need to hit second sign if you're using sign. So, stop. There. So second sign of whatever you have. Okay? Again, make sure your mode is in degrees. So if you're on the 83 or 84, switch it over here to degrees, and then hit quit to get back out here. Okay? Now I want you to think about, we're going to do a few of these here. Let's think about this first one. This is just solving a basic trig equation. If sine of x is 0.5, I know you could get this using your brains with the unit circle, but let's think about the algebra. I would take the inverse sine of both sides. Okay? Now, a function and its inverse cancel out, right? So what's left on the left side of this equation? X. So x is going to equal whatever the inverse sine of 0.5 is. Alright? So on my calculator, I'm doing second sine of 0.5, and that gives us 30, right? Did anyone not get that with their calculators? Please notice this sine -1 is not a cosecant. This is an inverse sine, the arc sine. Cosecant, we would do 1 over sine, all right? And that would not give us an angle anyways. All right, so any questions about that so far? All right, what I want you to do here is we already got 30 degrees. Okay? I want you to go through the rest of these and find answers for them. Okay? Just use your calculator, write down your answers, see what you get. Okay? I'm checking. You have your calculator with you? And you can round your answers. For one thing, I want you to give your answers positive. A positive answer. So if you get a -1, what do you need to do to it? What? If you get a negative angle, find the coterminal angle, which you do by just adding 360 to it. Okay? So just add 360 to it if you get a negative angle.
Excuse me, do you know how to make it degrees for the inspire?
Okay, there's a couple of things here. If you're in Scratchpad, it's always in radians. But what you can do, if you do trig and do the inverse sine of the 0.5, if you go out of the parentheses and then see the little pi button here, there's a degree symbol right there. If you put that in after it, oh, it should. Hang on.
Where Trig?
Oh, I didn't see that.
Wait, Mr. Dixon, did you say on the Inspire, like, Scratchpad's always in radians?
Yeah, it is.
Yeah, it is.
So then my answer is wrong.
So what I would do, if you've got the Inspire,
So x equals
hit the home button and go to the document. Like, go down to the calculator in the document. And then if you hit menu,
Add calculator?
yeah, add calculator. Under settings,
I still got 30.
document settings, you should get 30.
I still got 30 the first time, even in radians. What did it? How bad? Like, without.
Well, then you must be in radians. Or you must be in degrees.
So for Scratchpad, so I can use Scratchpad?
I don't know, somehow yours must be in degrees or something. You can change your document settings to make your document in degrees. Okay? And then what you could do with this then is just like make that the default for your documents. Okay, this actually saves it as your documents and Scratchpad. So, okay, yeah, so actually if you hit make default in your settings,
Yeah, I have it in degrees.
okay, it'll make it the default for your Scratchpad as well. Okay. Now, you need to be able to switch between them.
So how do you do
So if you go to your, I would go into a document and do your document settings, you could change it to radians at that point.
how? You just go to add calculator and menu.
If you go back to home,
Yeah.
the number 5 is settings,
Oh, no.
and there's a little drop down where you can choose radians or degrees. Oh. Thanks. Okay, so are we getting these?
Hopefully.
All right. So if we have the cosine of x equal to 0.7, x equals the inverse cosine of 0.7, right? And what do you get when you plug that in? 45.57, okay? And you can round that to 1 decimal place. Okay?
Do you always want us to round to 1 decimal degrees?
For right now, you can. It's for this moment. All right. Tangent. Tangent of x is -8. So x is going to be your inverse tangent of -8. All right. What do you have for inverse tangent of -8? Somebody.
277.1.
277.1.
Yeah.
Okay.
0.13.
Good.
Oh, yeah, that's right.
Good. All right, 277.1. And then we have, I'm just going to get those down there. Oops. And then you have the sine of x is a -0.8. So x is going to be the inverse sine of a -0.8. What do you get there? 306.9. Okay. All right. Cosine of x is a -0.2, so x is the inverse cosine of -0.2. Okay. What is that? 101.5. Okay. Is everyone figuring out? Is everyone getting these on their calculators?
Yes.
Okay. You all right? Okay. So then our final one, tangent of x is a -2.3. So x is the inverse tangent of -2.3. Okay, so what do we get for x? 293.5. Okay, 293.5. So here's the only problem. Okay, the problem is I got different answers. I got different answers than you did.
You're wrong.
One of us is doing.
Well, what about the rest?
Okay.
It must have been radians.
Are those other three the same?
42%
No,
sure.
I got 233.1. I got 258.5.
Did you use
Were you
inverse
radians?
cosine or radians or?
No, it's not radians. It's not inverse cosine or.
Which one's right?
Which one is right? What do you guys think?
Are they both right?
Both.
This is a trick question.
Ours.
How could they both be right?
Coterminal?
Hang on, Caitlin.
Because if you had
Or from
if you had x is 30 degrees, the sine of 30 degrees is the same as the sine of 150.
Okay, the sine of 30 is the same as the sine of 150. Why is that the case?
The reference angles.
The reference angles, okay? The reference angles. So, we have a 30-degree reference angle, and this is where trig equations are a little different than regular equations because these equations are going to have actually an infinite number of solutions. Okay? You guys already know 30, I could add 360 and get a coterminal angle, right? So 390, if you do sine of 390, you're going to get a half. If you do sine of 390 plus 360, you're going to get a half. If you did a sine of a -330, you're going to get
a half. Okay? Because they're all the same angle, they're coterminal. So that's one way we actually already have an infinite number of solutions. But we also have this idea of the reference angle. Think about this. Sine is positive 0.5. Where is sine positive in our quadrants?
First and second.
First and seconds. Okay? First and second quadrant. Let's put our phones away for good. You can pick it up at the dean's at the end of the day if I see it again. So if sine is positive 0.5 two different times in that first 360 degrees, that means I could get two answers, one in the first quadrant and one with a reference angle of 30 degrees in the second quadrant. Okay? So if I have a reference angle of 30 degrees in the second quadrant, remember reference angle always goes between the x-axis and your terminal side. What angle is this? It's 180 minus 30, 150 degrees. Okay? Does that all make sense?
Yeah.
Okay? So, as you're solving these, you need to do something along the way, and that is identify what quadrants you need. Sine is positive in the first quadrant and in the second quadrant. Cosine is positive in the first quadrant and in the fourth quadrant. Okay? So, notice here the first quadrant angle, 45.6, is my reference angle. I have to have a reference angle of 45.6 in the fourth quadrant. Well, that's 360 minus 45.6 gives us 314.4. Okay? Tangent is negative in which two quadrants?
Second, fourth.
Second and the fourth. Okay? Sine is negative in which two quadrants?
Third and fourth.
The third and the fourth. Okay? Cosine's negative in which two quadrants?
Second and third.
Second and third. Okay? Now, tangent. Where is tangent negative?
Second, fourth.
In the second quadrant and in the fourth quadrant. This one's in which quadrant? Fourth quadrant. Okay? So this angle should be in the second quadrant. Go ahead and take a moment and find it. What do we have to find first? The reference angle. Okay. What is our reference angle in this case? Good, 66.5. Alright, so 66.5. Here's the 293.5, this is 66.5. We need that same reference angle in the second quadrant, right? So this answer right here is going to be this angle.
113.
113.5. Okay?
How'd you do that? Oh, you just subtract from 180.
Yeah, you just subtract from 180 to get it. Okay? Does this make sense? Okay. Now, one thing I'll point out to you. Notice your answers are what the calculator was giving you, right? I mean, you got some negatives that you converted into positives by adding 360, but notice the quadrants your calculator is going to give you. When you're using sine, the calculator is going to give you the first quadrant, and down here the sine give you the fourth quadrant. Okay, what was our domain that we limited sine to? It was between -1 and 1, but
Negative radical 2, pi over 2 and pi over 2.
yeah, negative pi over 2 to pi over 2. That was the fourth and first quadrants, right? Negative pi over 2 is the fourth quadrant up to 0, and then from 0 to pi over 2 is the first quadrant. So your calculator is always going to give you an answer for sine that's in first or fourth quadrant. And then cosine, we limited it to what?
Pi and
0
0.
to pi, yeah. So that's which two quadrants? First and second. So check this out. When we did cosine, we got answers from the calculator that were in the first or second quadrants. Okay? This is what I was telling you. Your calculators know these ranges here. Okay? The range from 0 to 2 pi. The range from negative pi over 2 to pi over 2. Okay? And then tangent. Remember, tangent also had the range from negative pi over 2 to pi over 2. So that's the fourth quadrant. And we got a second fourth quadrant. I gave you two negatives on the tangent. That's okay. But it will give you either the fourth quadrant or the first quadrant again. And then you'll have to find the others yourselves. Okay? So guys, your calculator is not... It's a great tool, but you got to keep thinking. Okay? And another thing I'll say you need to think about is if you're given something that's from the unit circle, you don't even have to use your calculator. Okay? So, just to summarize all of this, how do we find angles that are outside the range? All right, here's our arc cosine, our arc sine in red, our arc tangent in green. How do we find angles that are outside the negative pi over 2 to pi over 2 or the 0 to pi? Well, consider, all students take calculus, consider the signs in your quadrants to find which quadrants your answers need to be in. So when you're doing an equation like this, before you even bother solving it, if sine is a positive, say I know I've got to get an answer in the first and second quadrants. Okay? So once you know which quadrants you need, then you're using the calculator or the unit circle to get one of your answers. Okay? And then finally, identify the reference angle to get the other one. Okay? And this is just something that I'll do for this class unless you see otherwise. Always give the answers from 0 to 2 pi. The directions may say just do 0 to pi. If that's the case, follow the directions. Or if the directions say go from negative 2 pi to positive 2 pi, just follow the directions. Okay? But if you don't see it stated otherwise, just go 0 to 2 pi. Calvin, what was your question? Okay. All right, so any other questions you guys have here? Okay. Now, on the practice for tomorrow, let me just make a comment. It seems like there's a lot of problems. However, this 1 through 9 right here, do these values look kind of familiar?
Yep.
All right. They look kind of familiar because they're all from unit circle. Use your unit circle. Okay? It is faster to think your unit circle and just write down an answer than it is to get out your calculator, make sure it's in the right mode, and punch it all in. Okay?
So would arc sine of 1/2 just be like the same as
same as 1/2, like sine 1/2, the unit circle.
Yeah, it'd be arc sine of 1/2. Think where is the sine 1/2? It's at 30 and 150. So I got two answers there. Okay? So, up here getting you used to the notation and the domain and range that we're dealing with. Here we're using the unit circle. And then you've just got a couple. You can use the calculator here, making sure you understand a little bit about the graph, thinking about that. And then there's a couple of problems similar to problems we've done in the past, dealing with right triangle trig. Except once you set up your equation, you're solving for the angle this time. Okay? Now understand here, even though mathematically there may be two solutions to the equation, think in terms of the context. Here theta is an acute angle, right? So I'm only going to give the answer that's between 0 and 90, not the other answer as well. Okay, so in word problems, you may have to decide which angle is the one you're really looking for. Okay?
Coach Nottage needs me in the athletic center. Is it okay if I go?
Yeah, the bell's going to ring in just a second anyway, so that's fine. All right.